Hello everyone, hopefully you are able to hear me. Thank you for coming in this earlier. So we are going to do the labs together uh, for CS281, and this is our course website. You know that we don't have a lab at each week, so before if there is a lab on that week, I will send you an email and also send you some handouts, sometimes backup videos, etc. At the beginning of the week to remind you. We are going to have 6 labs, so for the tutorial purposes, and each thing that we do in the lab has some corresponding stage in the project. So the labs are not graded, but it is heavily required for doing the project. And today we are going to start with drawing ER diagrams using a software called Draw.io. It's for general purpose diagrams, but we are going to use it to draw our ER diagrams. And for the project stages, design stage 1 and 2, we expect you to draw your ER diagram using this tool. And you are going to send the Draw.io file to us or upload it on Moodle. So for the attendance, this is similar to the lectures, so the weight is the same, and there is no like strict rules. So if you miss a lab, you can like easily follow us using the backup videos. And for each lab, we are going to give you some handouts. So this is the handout for lab 1, and in each handout there will be a section that follows that lab like a tutorial. So again, if you missed the lab, you might follow it from here. And in some handouts we have some exercises and also some additional summaries. For example, for this lab we have the ER diagram elements. So this is also the teacher's website. You can go to the TA's website from the announcements, and we keep our announcements. These are basically the mails that I send you. And for lab 1 you have the handout here, and we are going to use Draw.io. Additionally, starting from lab 2 we are going to use LibreOffice Base. So earlier we were using Microsoft Access to create our databases, and it was offered by the university, but it is no longer offered by the university for free. Therefore we are adapting to a free solution, and it is mostly similar to Microsoft Access, and you are going to do the project in LibreOffice Base as well. So you already sent your project group forms to Moodle, and we are going to like arrange the remaining members and distribute the project topics and announce them soon. And when we announce the project, we expect you to first look at the project description and draw an ER diagram out of it. And today our topic is how to draw the ER diagram. So if you go to this homepage, there is some materials, by the way, also for installing the LibreOffice Base. We made a guide. You can like follow it if you want. Uh, Installing is simple task, but one thing that may be required is also installing the JD key. That's one thing that you might be careful. Also, we are going to use the long-term support version of LibreOffice. So it is 646, and it's available for different OS. So according to your operating system, please install it before lab 2. So it's in week 5, there's time. And if you encounter any problems, you can contact us. So today we are going to use Draw.io, and it's an online tool. There are also desktop versions. So you can download it and use it when you are offline. But we are going to use the online version for simplicity. Going through draw.io. And if it is your first time going to this website, it will also ask you to choose a storage. If you like choose this, change storage, you can also choose the same. You have some cloud options, or you can save your files to your device, meaning that it's your desktop. So I'm going to choose the device, and you can click on create new diagram to create a new diagram. In here we have several templates, and there is also an entity relationship diagram. So this is the ER diagram, but it uses a different style. So one thing we should be careful about is there are several styles of ER diagrams, and we would like to use the one that the teacher introduces in the lecture. So otherwise it's problematic because the arrows change places and they could mean anything. So to be on the same page, be careful to use the same style of ER diagrams, which is not directly supported by Draw.io. So we are using the blank diagram template. So with blank diagrams, we can draw any diagrams. There is no like any restrictions on the items, etc. I have this part to write a file name. Let's say this is lab1 section 1, and I'm going to save it as a Draw.io file. You also have some options for like images, etc. But we want you to keep the Draw.io file because you can edit it for further. If it's an image, then you cannot load it back and continue working on it. By the way, if you have any questions, problems, feel free to interrupt me and ask. So right now I'm going to create a new diagram. And you have the option to like save it. But since I'm using my device as the storage, it will actually download that file. So every time I save it, it will download a new copy of that file with the number changing. So that's one thing that you should be aware of. So we also have this handout that we would like to follow. And basically, if we start with the summary of ER diagram elements and actually the databases, why we are creating databases is that we actually want to store some data, but not just some simple data. So if we were to just store a list of users, a simple text file will do that. But with a database, we would like to retrieve the data in different shapes. So for example, I might be interested in the users whose names start with the letter M, for example. Maybe I'm interested in an age group, etc. Furthermore, in a database, we keep the relations between different entities. So we might be storing users and classes, for example, and we might keep the relation about which user is enrolled to which class. This is going to be a relation, and we can keep such information in a database. And the retrieval of the data, for retrieving the data, we have some fast options in a database. If this was a simple text file, we need to go through each element if we are searching for a name, for example, with a for loop. But in a database, we have more quick ways to reach the data, which you will see in the further weeks in the lecture. But in the lab, we are focused on the project. So for each object that we store, we should have an entity set in our diagram. So entity sets refer to entities in our database that we store. And we should use the exact shapes. So for entities, we are using rectangles, not ellipses. So be careful about it. The symbols that we use are important, because if you use the wrong symbol, it would mean a different thing. So coming back to Draw again, this is our workspace. So if I have a mouse with a wheel, if I click on the mouse wheel and drag my mouse around, I can navigate in this workspace. You can also hold your space key on your keyboard and use your left mouse button to navigate around. You have the options to zoom in and zoom out. You can also do it by holding the control key on your keyboard and using the mouse wheel if you have a mouse wheel. On this left toolbar we have different shapes, and on the right toolbar it is a context sensitive menu, meaning that while different items are selected, we have different options on this right toolbar. So to create a new shape, what I need to do is just come on top of that shape and click on it. So I have my shape here. I can hold the mouse left button and drag this shape around, and you will see some blue dots around that shape that you can use them to resize your shape. There is also this little rotation symbol. If you click on it, it will make a 90 degrees turn for that element. By the way, you can also click and drag this rotation symbol for arbitrary rotations, but in the ER diagram we most of the time don't need such operation. You have this undo and redo buttons if you made a mistake, so right now I will undo it. You can also use the hotkeys Ctrl Z and Ctrl Y, the regular ones. And while a shape is selected, you will see that we have a bunch of options on the right toolbar. So we have some options for color, but in the ER diagram we are not using any colors. But one thing that we might need to use is the line width. So it was 1 point earlier. We need to use it just for the weak entities, but if you need to change it, it's here. We also have different line styles. For example, sometimes we will need dashed lines. It's there. And while a shape is selected, if I start typing on the keyboard, it will write this text on top of the shape in the center. And like I can resize my shape to fit it better. And this is going to be an entity. I know it because of the rectangular shape. And let's make it an entity for users. So if I write user here, then I mean that in my database I'm storing some users, any number of users. You can think it as a datasheet, as an Excel file for users. In that Excel file, I'm going to store different users in each row. And for the columns, I need to store some different attributes for the user. So if I just have the rectangular shape, it doesn't say anything about what I'm storing. Okay, the instances will correspond to users in this case, but I'm not saying which information I store for a user. Using attributes, we talk about that. So for attributes, we are using the ellipse shapes, and each attribute that we have should be connected to an entity set. So in this case, let's create a new attribute. So I'm going to click on ellipse. The ellipse shape comes up. Let's write name on top of it. I'm going to resize it into a better size. And this is my attribute. So I would like to say that this attribute belongs to the entity user. To do that, I connect them with simple lines. So the line is here. If I click on a line, it will bring it up. With lines in Draw.io, we should be careful about that thing, that there are two endpoints for a line indicated with these blue dots, and those can be attached to other shapes. One more thing about carrying a line. So usually we don't like carry the line as it is, but if you try to do so, there is also a hard to see, but there is also one more dot in the center, which you use for creating arcs. So if you click on the mid sections always, you can create arcs, which we don't need to use here. So I'm going to undo this, but by mistake, if you do it, don't be confused. So what I want to do is to carry these ending points on top of the shapes. And when you do that, you can bring it on top of the center of the shape. This will connect the line to the center part. You may also connect it to different anchor points around the shape. So for example, there is an anchor point on bottom right corner. If I connect it there, then it will try to stay there always. So I'm just carrying the shape. The line finds the way automatically. But if you connect it to those anchors in the outline, then it might be sometimes problematic when you carry around the item. So most of the time for us it will be more useful to anchor it in the center. So you just carry the endpoint into the center of the item. And I will do it for the other endpoint and connect it to the user entity. And you should see that when I carry the items around, it automatically draws a good line between them. And it's very useful because if you are designing the ER diagram on page, then it's hard to carry items around when some new part comes up. That's why we would like to use this tool. So let's try to get this picture. So I need the surname, password, and ID attributes. So most of the time we reuse the items that we have, that we already have, because if I create a new ellipse, then it will have this default shape. I need to resize it, etc. I need to find my line in the toolbar. Instead, I can just right click on one of the existing items and choose duplicate. So it makes an exact copy of the same item. Then while this shape is selected, I can double click on the text to edit it, and I can change it into surname, for example. And to duplicate elements, the hotkey is also visible here. It's Control D. If I click on the shape and hit Control key on my keyboard, it will make a new copy of it, and then I can write ID here, for example. While that shape is selected, on the right toolbar I have the text options. If you go there, you can underline your text. There are also different options for the text, but this default font and default font size is okay for us. So you can also choose the existing lines, use Ctrl D, and connect them to different shapes, which I will do to connect my other attributes. You can also choose one shape, and while holding the Control key, you can choose multiple shapes. And again, using Control D, this time I will make a copy of the both items. Then I just need to connect the other end to the entity, and then I need the password attribute. So this is how I connect attributes to entities with always simple lines. In some certain cases, we have different lines, but they are not in between attributes and entities. They will be between entities and relations. So coming back to here, we also store relations in our database. So right now we have a user entity. Let's say we have some course entity as well. I'm going to drag my mouse with the left button and choose the entity and its attributes and use Ctrl D to duplicate it and have a separate copy of it here. Let's get rid of some of the attributes. You can right click on a shape and choose delete, or you can just choose the shape and hit the delete key on your keyboard as well. So I'm going to turn this into a course entity with CID for course ID, and let's say we have CNAME for course name. And I would like to relate the instances of users and courses together with a relationship. The relationship symbol is a diamond, so I'm going to click on diamond to bring a new shape here. And let's say this is a relation for being enrolled to that course. Let's say enroll. So I will again resize my shape to fit the text better. And I would like to say that these are related with the relation enroll. To say that, I need lines again connecting the entities with the relationship. So I will make duplicates of one of the lines and connect them with simple lines first. This means that a user can enroll to a course, or if you read it the other way around, a course can be enrolled by a user. And with relations, we also talk about different constraints. One is the participation and the other is the cardinality. But first, what a relation means for us is, so we compared entities to Excel sheets, right? Data sheets. I have an Excel file, I have a bunch of users, and in a separate Excel file, let's say I have a bunch of courses. Relations can be interpreted as tables as well, similar to, again, an Excel table. But in that Excel table, I need to store which user is related to which course. So instead of keeping the whole user, I don't need all the columns. I just need the primary key of the user. Why? Because with the primary key, I can find a unique user. So in this new table about the relation, I just need to store the ID of user and CID of course to relate a user to a course. So enroll is going to correspond to such a table. In that table, I only keep two things, and these are the primary keys of my attributes. There could be a composite primary key. Two things can be the primary key of a table. For example, if this was the case, I need both the ID and the password from user. Or if this relation connects to multiple entities, more than two entities, then again, I need the primary key for all of the entities, because I need to relate different instances in different entities. With additional constraints, we give more detail about our relation. So first, with participation. With total participation, if we have a bold line on one of the sides, this means that, so for example, in here, teacher teaches courses. If I have a bold line that connects teacher to the relation, this means that every instance that I have in this table should contribute to this relation. In other words, I would be saying that if I have a teacher in my database, that teacher should teach some course. Which course, I don't know, but it should be in this relation. On the other hand, for courses, we don't have such constraints. There could be some courses that are not taught by anyone, and some of them will be taught by teachers. But for teachers, there cannot be any teacher that is not teaching. All the teachers should teach if we look into this picture. So we already talked about how we make the bold lines. While this line is selected, if I go under this Style tab, I have this line quality and also the line width. I can make it thicker. In our case, it will mean that if we store a user in our database, that user should enroll to some course. Which course, I don't know. It could be more than one course, but we are saying that each user should enroll to at least one course if we do it so. I can also have total participation on the other side. Then this time I would mean that each course should be enrolled by at least one user. So I should not have any courses without any users. There should be at least one user for every course. There is also the concept of participation. Okay, this was the participation. There is also the concept for cardinality. And cardinality talks about how many of one entity is related to how much of the other one. So in the basic case, we have like three main cardinality constraints. Many to many, it is the one that we already made using the simple lines. What it means that for our diagram, many users can enroll to a course, and many courses can be enrolled by the same user. So let's say I have a user Ali, and this user can enroll to different courses like maths and CS, etc. And if I have a course on the other hand, for example for Turkish, and then in this course there could be multiple users. So many-to-many relations are a common case. Most of the time we have such relations. But sometimes we need to allow just one instance to be matched with one instance on the other entity. In this case, we have one-to-one relations, and we also have one-to-many relations. To show this one-to-one and one-to-many relations, we are using arrow shapes, arrow lines. And let's try to create a one-to-one relationship. While this line is selected on this right toolbar, we also have a shape option for line starting and line ending. But we are not sure about which side is the starting and the ending point, so we should try. So I'm going to choose the line starting point and choose this simple arrow shape. And it happens to be that this was the line starting part and my arrow is in the wrong position. So you can right click on this line and easily reverse it if it's in the wrong position. So we were talking about different styles of ER diagrams. In one style, the arrows are next to entities, but this is not our style. So in the style that we follow, if there is an arrow, that arrow should always be next to the relation. So I have my enroll relation here, and the arrow is just next to this relation. So I might also have an arrow on the other side. So on the course and enroll side, again, this is reverse. So I'm going to right click on this line and choose reverse, or you can use the hotkey Control R. So this is the correct one. If I have an arrow, it should be always next to the relation. So if I have arrows on both sides, then this means that this is a one-to-one relationship, and this means a user can enroll to only one course, and if we read it the other way around, a course can be enrolled by only one user. If these courses are like special lectures, for example, with just one people, then maybe in that case you might have such a picture. But one-to-one relationships are not that common. And we also have one-to-many relationships. With one-to-many relationships, we keep the arrow on one side and keep a simple line on the other side. And sometimes people confuse which side this arrow should be. And one thing to remember is one thing that we can use to remember it is this picture. So we have an owner with some dogs, let's say, and if you look at this intersection point, it is kind of like the relation point. So if we think the leashes, this connecting point is the relation, then on the dog side, it is kind of similar to an arrow because we have multiple dogs. And let's say for each owner there can be many dogs, but on the other side, for each dog there is only one owner. So the arrow shape is on the right. If you think the relation is in the middle, then we have this leashes that are similar to an arrow shape on the right. Then we have the arrow on the dog side to mean that one owner can have multiple dogs, but for a dog there can be only one owner. And if you also consider the participation, now we are not talking about total participation on dog side, meaning that there could be some dogs without an owner, and on the other side we don't have total participation on the owner's side as well, meaning that there can be some owners without a dog. But if there is an owner with some dogs, there can be many dogs. It could be only one dog as well, so that's also possible. But what we say is that we allow multiple dogs for an owner, but for a dog we are not allowing multiple owners in this picture. So here I can just get rid of the arrow on one side. So this time it will mean that one user can enroll to many courses, but for a course, in a course, that can be only one user. In this case, it doesn't make very much sense, but if I remove the other arrow, then what I mean is a user can enroll to just one course. Maybe it is a special term where you can just enroll to one course, but in a course there can be multiple users. In some courses there can be just one user, that's also allowed. There can be no users in some courses, that's also allowed. But what I'm talking about with this one-to-many relationship is that I allow multiple users to be in the same course. And secondly, I'm also saying that the same user cannot appear in different courses. For each user, there can be only one course. So we can easily mix and match cardinality with participation. So I can have total participation on one side. It could be a one-to-many relationship. It can be one-to-one relationship with total participation on both sides. Sometimes we need to use the same entity for a relation twice. In that cases, we might need to write the role on top of the lines that connect entities to relationships. So let's do a similar example in our case. Let's say that users are friends of other users. And in this case, let's say that the friend request comes from one side to the other one. So I'm going to duplicate my relationship and let's write friend of for this one. So I would like to connect the user entity twice. So I will have a new line here. So if I do it the usual way with the center points, this time it will be problematic because the new line will also find the shortest way the same. So I have the two lines overlapping. In such cases, it is better to use the anchor points. So if you look closer, when you bring the line on top of the shape, there are different anchor points on the outline that's shown with little blue crosses. So I'm going to connect my lines to those anchor points, and on the relation side as well, I'm going to use those anchor points. This time the lines would be connected to that anchor points, and what I need to be careful of is that if I carry my item to the other side, then I need to somehow fix these lines. So we should be careful with such usage. So I would like to write the rows. While the line is selected, I can start typing on my keyboard. Then it will be on top of my line. Again, if I carry the item, the text will follow. And with such setup as well, you can have one-to-one, one-to-many relations as well. The arrows should be next to the relation again. With such setup, we talked that there could be a table for the relation. In that table, I'm keeping two users primary key, so one ID for the from side and another ID for the to side. So these can be two different users. We also have ternary relations. With ternary relations, we are relating two different entities. All the participation and cardinality constraints still apply to the ternary relation. We just have one additional entity that is used in a relation. So I'm going to duplicate this course, and for this one, let's say we have classrooms, and instead of a CNAME, let's write maybe the floor number for the classrooms. And the naming can be the same for attributes of different entities. So I can have a CID for course. I can also have a CID for classroom. This time maybe meaning the classroom ID. I can write them longer, but when you go in the implementation, the shorter and meaningful names help. So I also connect this new entity with a simple line to enroll. Then what it means is that when a user is enrolled to a course, we also relate a classroom in this relation. With ternary relations, the cardinality could be sometimes hard to read. It's not that hard, but we have three different things. With the cardinality, when there are two entities, it is easy to read when you have one-to-many. If all of them are ones, so if we have an arrow on each side, then it's again easier. If we have simple lines on each side with a ternary relation, it's again simple. But when you have simple lines on some sides and arrowed lines on some entities, it could be hard to read. In that cases, you may hide one side. So I'm going to just delete this part for now. You can hide one side and read it the usual way. So dogs are like the users now. In a classroom, there can be multiple users, but each user should be in just one classroom. So if I get rid of this left part, then what it means that there could be many classrooms for a course, and there could be many courses for a classroom. So how you read is by just hiding one side and you reading it the usual way. And like most of the time, if you have a ternary relationship, then either you have all many, and you might have one-to-one, but the common case is when you have many. So that's more common. In the other cases, there aren't many examples. So in this setup, let's also say that we don't have an arrow on user side, and users are being enrolled to courses, and for courses we are assigning classrooms. And let's say some of our classes are online, and for such classes we don't need to store the classroom information. So that we could create a new relation between user and course, right? It could be something like online enroll, for example. The main name is not that good, but I can have a separate relationship. But then it makes things complicated. So for online enroll, we are using a different thing, and maybe we are keeping the grades, and we would like to make some operations based on the grades. And using two different tables for each of these relations are not that good. But if I just use the ternary relation, and if there are lots of online courses, and maybe let's say only for some portion of the courses we are using classrooms, then for the table of enroll, I will have users matched with courses, but in most of them, I will have empty classrooms. So for the classroom column for this table, I will have nothing. If a classroom is assigned, I will use its CID, but otherwise that column for the primary key of the classroom would be empty. And if there are so many cases like this, then we are kind of wasting storage, because for each row we should store the same, so maybe I should say it like that. For each instance that we store in that table, it could be for an entity or a relationship. For each instance that we store, we have the same memory space, and either we use it or not, it doesn't matter. We allocate that space, and if we are not using it, if it's empty most of the time, then we are wasting our space. So we should design the relation in a different way inside setup, and we use aggregate relations for that purpose. In this one, we are basically relating the relations together. So we are using an existing relation like an entity to relate it with some other entities or some other aggregate relations. So let's do it with an example. To show an aggregate relation, I need a rectangle with a dashed outline. So I'm going to create a new rectangle here, and I will make it bigger. But you will see that it overlaps our existing shapes. So in Draw.io, it uses a layer-based system. You can right-click on any of the items and send them to front or back. This time I will send this item to back. So the dashed rectangle should include the relation and also the entities that are connected to that relation. And to make it dashed, I will go under the style options, make it dashed. So within this dashed rectangle, there should be just one relation. It is enroll. So if I make it bigger, if it also encapsulates this other relation, then it doesn't make sense. Because what I would like to do eventually is to connect this new relation. So I don't have that new relation yet. Let's first create it. So I will create a copy of this relation, and let's call this one something like have. So for that class, we would have a classroom, for example. In this case, actually, the enroll is not that meaningful. Maybe we can turn it into teachers. So these are, let's say, similar to teachers. Teachers are again teaching courses, and for that courses we are going to assign classrooms, because with students, if they are enrolled, then for the enroll operation, if we keep this classroom separately, it is not that meaningful, because for the course we will give the classroom that time. But this setup works better with teachers teaching courses, and sometimes we would like to assign classrooms to those teaching activities. By the way, I should also mention that if I carry this shape on top of the line, it might look like as if it is connected, and like in some if you yeah, okay, if you bring the shape on top of the line, it connects it into the middle, so be careful about it. But if you carry it on top of the ending points, it doesn't anchor, so you should carry the line into the shape. So I'm going to create a separate line to connect this new relation have to my aggregate relation. So in here, teachers are teaching courses, and for those courses we have the option to assign a classroom. Okay, I should write assign here. So I can assign a classroom to some of these courses that are taught by teachers. A different setup could be to directly connect courses to classrooms, but this does not assure that course is being taught. So for example, if I give the classroom to a teacher on teacher basis, then what I mean is that I'm giving the classrooms to the teachers for users for using, and the teachers decide about which course to teach in that classroom, and maybe there could be lots of classrooms for a teacher, and that teacher maybe does not have that many courses, and we can have some imbalance. I might give or assign the classrooms to the courses, but maybe those courses are not taught. So in this case, the better thing to do is to assign it directly to the relation. We are actually trying to say that for this assign relation, we are connecting on top of the teaches relation. So I'm actually connecting the relations, but that's not how I show it. To show it in the ER diagram, I show the existing relation within a dashed rectangle. So that's why there should be only one relation in this dashed line, dashed rectangle. Otherwise, I am not sure about which relation to connect. And we also include the entities that are connected to that relation for visualization to show it. So for a teaching activity, I can then assign classrooms if I'm going to use a classroom for that purpose. Otherwise, for online courses, I just need this teaches relation. And if I need to find the courses that are taught in a classroom, then I'm interested in this assign table. And if there are some attributes of this relation, for example, for the teaching activity, I might be keeping some additional information. It could be like some credits, etc. And this assign would know the credits of this teaching activity because it is defined on top of that. Any questions, problems so far? So let's give a 10 minutes break. We will meet at 9 o'clock. So I should write that. Okay, let's give a break. So Ahmed asks whether dashed line means it's not always related. No, actually, the dashed line here means that we encapsulate this part, and then we can relate it similar to an entity. So teaches is not an entity, it's a relationship. But what I do is, with this dashed rectangle, I'm saying that this part as a whole kind of acts like an entity, and then I can relate it with other entities. Is it clear? So why we come to the part saying that not always related is because it is related with a different relationship, and there is no total participation on this side. If I had a total participation in here, then it would mean that for every teaching activity, we should assign a classroom. Then a ternary relation would also make sense in this case, if I'm assigning a classroom for all of them. But not always part comes from this simple line, because it is connected with without a total participation. Evet. Yani burada tam olarak kim karar veriyor gibi değil de şöyle düşünebilirsin. Yani burada şöyle diyoruz, işte öğretmenler dersleri veriyor. Bunu ayrı bir yerde tuttuk. Ama öğretmen dersi verirken bu aktivite için, yani doğrudan relation için bir classroom assign edebiliriz. Ayrı ayrı bağladığımızda şöyle oluyor. Classroom'u öğretmene assign ettik veya classroom'u derse assign ettik oluyor. Ama öğretmen dersi verirken assign edersek şunu garanti etmiş oluyoruz. O öğretmen bir dersi verdiği için classroom'a assign edilmiş oluyor. Mesela ders vermeyen öğretmenlere de classroom assign edebiliriz böyle yaparsak. Veya öğretilmeyen derslere classroom verebiliriz diğer tarafa bağlarsak. Bu şekilde yaptığımız zaman hani o öğretmen bir dersi verirken classroom'a assign ettiğini garanti ediyoruz. Hı hı, önemli değil. Any other questions, problems? Okay, let's give the break. So hello again, let's continue. I should also remind you that I'm also recording these labs, so we have the backup videos that I record before the lab in case you miss the hour. But we also record the lab hours so that maybe there was some like additional discussion that was not available in the backup video, etc. If you would like to look at it again, that's why we are recording, and like I will send you links for them. So with aggregate relations, within this dashed rectangle, we can have total participation, different cardinality, and in the outside part, we can again have total participation and cardinality. So for example, if I have a bold line here, then this would mean that for every teaching activity, I should assign a classroom. In such setup, if I have total participation for this aggregate relation, for the aggregate part, then a ternary relation would make more sense. Why? Because I'm basically saying that every time I teach, it should be assigned to a classroom. And with the ternary relation, we are already having such setup. With the ternary relation, we basically try to say that, okay, these three entities are always related together. With the aggregate relation, we separate these connections. We have two different relations, and therefore, sometimes maybe the activity is not in a class, maybe sometimes it's online. We have different possibilities with the aggregate relation. But in the relation in, or in our case, the assign relation, let me make it the simple line again. So remember, in the teachers relation, we keep a reference to the primary keys of the entities. So in teachers, I should store the ID of the teacher that I relate to a course. Then I also need the CID of a course. And I might have some additional attributes within this table as well. For example, a credits column. And with the aggregate relation, for the assign relation, I need the primary key of the relation this time. And for this relation, the primary key is the ID of the teacher combined with the CID of the course. because this is a many-to-many relationship, and to find a unique entry in the table, I need both the ID of the teacher and the CID of the course. So these two help me to find a unique entry if we are talking in terms of tables. In the ER diagram, we show entities and relations, but when we go into the database, in the database, everything will be a table. And how we use those tables, we decide that. We can use some tables to represent entities, and for some tables, we can use them to represent relations. And each table, we basically need some primary key. So for entities, we are already showing them in our ER diagram, but for relations, we are not explicitly showing them. So we determine it by looking at the entities that are connected to this relation. So for teachers, it is connected to teacher, therefore I need a reference to its primary key. So we are going to say a foreign key for this one, foreign key for teacher's ID, and a foreign key for course's ID. On the other hand, for the relation assign, we are going to define it on top of teachers. Therefore, I need a reference to the primary key of classroom, and on the other hand, I need a reference to the primary key of teachers. And I just mentioned the primary key of teachers is ID and CID from teacher and course. So in here, I will have three different, for example, foreign keys. But we will discuss this foreign key concept in the upcoming weeks, and you will also see it in the lecture. But just as a small information. So we also have an is-a relation to create hierarchy. And this hierarchy should define some difference. So it should be used for a difference in between the children of a parent. So we should have just one parent. So we show the is-a relation with a triangle pointing towards up. And on top, there should be just one parent. And on the bottom side, we have multiple children. And for this relation to make sense, there should be some sort of difference in between the different children. So let's create an is-a relation here. Let's say that there are different kind of teachers maybe. I'm going to create a triangle shape. And since I changed the line type at the last stage, the new items follow that new line type. So if I bring new shapes, it uses the same line that I just set up. So I should switch it back to simple lines. Then when I bring a new shape, it has the simple line. Or if I change the width, for example, the new shapes follow the same line quality. So be careful about it. So for this new triangle, I'm going to set it to solid line. And to rotate it, I will click on this rotation symbol 3 times to have the correct rotation. Then I can type something on top of it. Sometimes people, by mistake, drag it with an arbitrary rotation. In those cases, if you write the text on top of the triangle, it doesn't have the correct alignment. So if you rotate the triangle, it also follows with the text. If you click on the rotation symbol, it just rotates the shape, not the text. So we want this. We don't want the text to be rotated because we are going to use it pointing towards up. So clicking on the rotation symbol is better for us. And on top, I'm going to write is-a, and you can like put it into the next line with the enter key so that it is centered. The parent should be at top. I will create a new line and connect them together. This time it's more meaningful to use the top anchor. So for connecting the line to this triangle, I will use the top anchor so that when I carry it around, it is always connected to the top point. And I'm going to have some children for this teacher part. And let's say maybe there are some standard teachers, I don't know, and we might have like some professors and maybe some teachers are managing the school. Maybe the manager is not a good word for it, but let's go with it. So I will create new lines connecting these entities, this time to the bottom side of my is a relation. So I can use the bottom anchors for it. Meaning that these are the children of teacher, and they will inherit all the attributes of a teacher. So in the standard entity, there is ID, name, surname, and password. For prof, we have the same thing. For manager, we have the same thing. And they also inherit the relation capabilities. So I was saying that a teacher teaches courses. Manager is also a teacher through this is a relation. So manager could also teach courses, prof could also teach courses, etc. But if we do not add anything else, then this could be replaced by an attribute like type. So I can write type for teacher and replace it like this. I can store whether this is a standard teacher or a professor or a manager in an attribute. So with the is a relation, we actually would like to create some difference in between these children. Like for example, for managers, we might store additional information. Maybe an additional payment, like this manager could spend some payments for managing the school. I don't know. Maybe that's not a good example, but let's keep an additional attribute for the manager. Maybe the professor could do research. Maybe we have, let's say, a separate entity for research. And they can give these research tasks to different people. So when I have a difference in terms of attributes or relation capabilities, then using the is a relation makes more sense. So now I say that, okay, manager inherits the attributes of the teacher, but there is also this additional attribute payment for a manager that is stored. Okay, professors inherit all the capabilities of the teacher. It could be like the friends of other teachers. It can teach courses, but additionally, professors can give research tasks, for example. Standard teachers or managers cannot do that. And for professors, we don't have any payment attributes. In this case, for research task as well, there will be like some attributes. Of course, I am not showing them, but for every entity, we should have some primary key and some attributes. Otherwise, just storing the primary key is not that helpful for our data. Maybe the research name, for example, and I don't need to underline. The hotkey for underlining is Ctrl U on your keyboard. So if you go in the text and hold your mouse on this button, it also shows that. So with an is a relation, I create hierarchy and I expect some difference in between the children. There is also weak entities, which are not that common, and sometimes people do mistakes about them. Let's try to create this picture in here. So in this case, customers are borrowing loan from our bank, let's say. And maybe we can do it for our existing entities instead of customers. Maybe standard features are getting loans. I don't know why. Not a load. Let's do it with a new entity, because with the weak entities we basically identify the weak entity through the relation, and since in the standard user we inherit the ID of teacher, it's not directly shown here. So for the children we don't specify the primary key directly because we already know that it will inherit the primary key of the parent. So seeing the primary key directly in here would help better, I think, to show it. So we have customers. Let's have their attributes. Let's say we have customer IDs and maybe customer names. And for the loan we were storing the date that we give this loan and also the amount. And I need simple lines connecting these attributes to the entities. And for the relation, for now, let's say it's a many-to-many relation without any participation constraints. This would be the picture. But for loan, let's say for just the loan entity, we just store the date and amount, and it's not possible to find a unique loan with just the date and amount. So if you consider that there could be some customers that are borrowing the loan on the same date with the same amount, always we can include some additional attributes, like something like a loan ID, some unique ID. Then in this case, if I can achieve some setup, there is no need for weak entities. And in the most case, for loans, for example, the real life examples use such setup. They assign some unique numbers to the loans and like for payments, transactions, etc. That's why it is sometimes kind of hard to understand the weak entities because they are not that common in real life examples. But let's say that for loans we just keep the date and amount, and just knowing them is not enough to find a unique loan, because on the same date there could be multiple entries in my table with the same amount. And in such cases we uh, identify a loan through this borrow relationship, and in that case we say that okay, loan is a weak entity. To show that, we make the entities line thicker and also the relationships line thicker. So I should use thick lines for the weak entity and the weak relation. And I need total participation on this right hand side, because if I can only identify a loan through this relationship, then if that loan is, if it is not in that relationship, then I cannot identify it. That's basically why I have total participation. I have to have total participation on this right hand side. Additionally, if a loan can be borrowed by different customers, if the same loan can be borrowed by different customers, then again it's not meaningful, because we are already saying that I need the customer information to identify a unique loan. If I allow multiple customers to borrow the same loan, then I have problem, right? So that's why I also need to make it a one-to-many relationship. So this is the picture that we have for weak entities. And we are not just using the customer ID, right? The same customer can borrow multiple loans. So if that's the case, if for the same customer there are multiple loans, then we need some more information to find the unique entry. So in this case, I can use the combination of date and amount. For example, on the same date, the customer can get different amounts, but let's say there is some restriction. On the same date, the same customer cannot get the same amount of loan. For example, let's say this is our limitation. I need a dashed line under the partial keys. So the keys of the weak entity is called partial key because they are not enough to identify a unique entry for the weak entity. We use the primary key of the entity that we are connected to through this weak relationship. But to show the partial keys, because the partial keys are also used to find a unique entry. For the loans, there could be maybe some additional descriptions. I can have some other fields, other attributes for a loan that are not the partial key. But for the partial key, I need the dashed underline, which is not available in Drova directly. So therefore, I am going to include a dot line. So it's a line with a dash, and anchor these lines on the bottom right and left corners of my ellipse shape. So this is how I show that the attribute is a partial key. So if you anchor them right when you carry the item around, it will follow that ellipse shape. And description is just a simple attribute. It's not a partial key. I don't have any underlining there. So this is the picture we have for weak entities. But sometimes people mistakenly think it like this. So let me go to this ER diagram we have here. And people might think it like this. Sometimes they say that, okay, we have teachers and courses. If there were no teachers, then there would not be a need for courses, so let's make course weak. If there weren't any courses, there wouldn't be any students, let's make student weak. So this is not how you should approach. So this is a false approach. How you decide on a weak entity should be like this. You should ask whether I can find a unique entry for this object by just looking at the attributes of that object. So in this case, for customers, for example, I have the unique CID, right? For teachers, in our example, we have this unique ID. This unique ID is enough to find a unique entry for a teacher. For courses as well, we have this unique CID. To find a unique course, I have the enough information in my attributes. The problem with a loan is that I don't have enough attributes, or I don't have some attributes that uniquely identify a loan. I just keep the date and amount. There is no something like a transaction ID. There is no some loan ID that I store that is used as a unique identifier. And that's why I need the customer's information, customer CID, to find a unique loan. In your projects as well, the weak entities are not that common. So don't force it too much to find a weak entity. Sometimes with additional assumptions, you can create weak entities, but like if there is no unique, if there is no weak entity in your project topic, that's okay, that's not a problem. Don't try to create weak entities because weak entities have some limitations. You are putting some limitations, some restrictions. So in here, you cannot create a loan directly. You need to create the loan and directly attach it to the relation. So they create some difficulties. So I can, yeah. So partial key is uh, in this setup for identifying a unique loan. I use the partial keys and also the primary key of the customer. So primary key of the customer is required, but on top of that, since the same customer can get multiple loans, to identify the unique loan, I also use the date and amount additionally. So it might be just the date as well. So let's say we give loans on different dates. So on the same date, if a customer cannot get multiple loans, if this is our restriction, then this is okay as well. Then I'm using date additionally to find a unique loan. Is it clear now? Okay. So if there is no partial key, then that's a problem. So you should be also careful about that. If there is no partial key, then if I allow multiple customers to have, if I allow for the same customer to get multiple loans, then having no partial key uh, does not make sense. In that case, I need a one-to-one relationship. So if it is one-to-one, I can have no partial keys, but if I allow if I allow each customer to get multiple loans, then I need some partial key on the right hand side because otherwise I cannot find a unique entry. So in your projects, you are given some descriptions and we are going to do such an example. So we are given in the handouts some description for a database for a school. So in here, let's create a new diagram. Maybe it's lab 1 example. And let's try to follow the description because in your first design stage, you are going to do the same. So this could be a project topic. So the weight is kind of similar. Maybe in your projects, you have 2 or 3 more entities, etc. But this could be a project topic as well. So we are going to follow it and we actually have the diagram here, but how to make sense of the sentences to see that we are going to go through that. And it says that you are going to design a database for a school. And with most of the project descriptions, we start with some rough information about what is this going to be. And sometimes people could do the mistake of including the school as an entity. So be careful about it. We are designing this just one for school, right? And if I have an entity in my ER diagram, then I'm saying that, okay, I need to store multiple instances inside that entity. So entities are used to store multiple data, right? If I include the school entity, then that means that I'm doing it for multiple schools. There could be multiple schools. But I'm going to design it just for one school, so be careful about it. So right now, this is just one rough information about the database. Users of this system have unique ID number, name, surname, and password. So from here, I can understand that there would be some users stored in my system, and these users are stored with a unique ID number, name, surname, and password. So these belong to a user. So these are in case the attributes, and the user should be the entity. So I'm going to create a user entity with ID, name, surname, and password. We have already seen how to create them. So I will include a new rectangle, write user on top of it, and let's also create the attributes for name. I will resize it and duplicate it. We have the surname. We need the passwords. I'm using the key Control D to duplicate my shapes. And we have the ID, which is going to be the primary key. Therefore, I underline this item. And I need simple lines connecting my entity to the attributes. And be careful, if the line is between the entity and the attribute, then there cannot be any arrows. And it cannot be tick, it should be the simple line. So it says that a user could be a student, a teacher, or a staff member. So far, it doesn't say me whether these students, teachers, or staff members have some difference in between. So far, it could be also just one additional attribute storing the information about whether this user is a student, a teacher, or a staff. But then it says that for students, system keeps track of amount of scholarship as well. So now I know that I should make it an is-a relation, because for a special kind of user, for students, I need to store additional information, the amount of scholarship. So now I will create the triangle, rotate it 3 times to have the correct rotation, write is-a on top of my triangle, and I could put the text on the second line to make it centered. So the parent is user because we have different kinds of users. And those user types are, I will duplicate this item. They are the student, teacher, and staff. For the children, I should connect them to the bottom side of the triangle. And we have some difference in terms of the attributes that we store. For students, it says that for students we need to keep track of a scholarship. So I will have an additional attribute, resize it, and I will connect it to the student. A student can enroll to many courses, and a course can have many students enrolled. So far, I already have my student entity, and we are talking about some activity between students and courses. This is the first time we are seeing the course word in the description, but if we continue, it gives additional information about courses. So whether something is an entity or a relationship, you can like look at the whole description, and if you can find some description saying that okay, for this we store a bunch of attributes, etc., then you can decide that this is going to be an entity. So it says that each course has a unique course code, course name, and an optional description. So from this sentence, I can understand that the course should be an entity with course code, course name, and description. So I come back to here, there should be some course entity. And for that one, I need to store the course code, which is going to be the primary key because it was saying that this is unique. The course name, let's write CNAME for that. And I also need a description. And these are the attributes of a course. Therefore, I should connect them with simple lines. It was also saying that the description is optional. Sometimes in the description of the project topic, we have additional information about the usage. Sometimes it can be an implementation detail. In this case, being optional is not something that we show in the ER diagram. So being optional is something that we decide when we create the tables for a database. So in each table, we have the option to make it required or not. So that's something for the further stages. That's not something we show in the ER diagram. So coming back, it was saying that a student can enroll to many courses. and a course can have many students enrolled. Now we are describing something between our existing entities. In such cases, we use relations to relate different entities. We know that course is an entity, student is an entity, and we are talking about some activity or some relation between them. Therefore, I need to use the relation. So this time it was talking about enrolling into courses. Maybe I can have a relation named enrolled, and I will start with simple lines first, and then decide whether I need to use total participation or different cardinality. So it is saying that a student can enroll to many courses. So for one student, it says that there could be many courses. And a course can have many students enrolled. So for a course as well, there can be many students. So from these manys, I understand that this should be a many-to-many relationship. We can use different words for it. We can say multiple courses, more than one courses, etc. But you need to be careful whether we are saying more than one or more than zero. So if we were saying more than one, or there should be always one course for a student, for example, then that would mean a total participation. But if we are just saying many or multiple courses, then we are just talking about the cardinality. There is no constraint for the participation. We are not saying that every student should be enrolled to a course. So it also says that a grade should be stored for each enrolled course. So students are enrolled to courses. This is my relation. And for that relation, I am storing a grade. So that grade is going to be in the relation. It also says that it should be in 0-100 range, but this is again an implementation detail. We are going to set this range in while we are creating the table. Every course must be taught by exactly one teacher. On the other hand, a teacher could teach many courses. Now we are talking about some relation between teachers and courses. So I will create a relation, this time teaches, between the course and teacher. And this time there is some information about the cardinality as well. It was saying that, if you come back to here, it was saying that every course must be taught by exactly one teacher. So every course must be taught by some teacher, and that is exactly one teacher. But a teacher can teach many courses. So with the cardinality, a teacher can teach many courses. Courses are similar to dogs if you compare it with our picture. So therefore I need an arrow on the course side. And additionally, I'm saying that every course must be taught. So there cannot be any courses lying around. Every course, if I have a course, it should be taught by some teacher. Therefore, I need the total participation on this left side as well to make every course being taught by a teacher. But for a teacher, teachers does not have to teach courses. But if they teach, it's okay. They can teach multiple courses. They can teach just one course. These are all okay. But for courses, there should be exactly one teacher that is teaching that course. Every student should have one teacher as their advisor. A teacher may be the advisor of many students. So this is again a similar relationship, this time between the student and the teacher. So we might have this advisor relationship between the student and the teacher. And it was saying that for every student, we need an advisor and should have one teacher. It's not saying can have, it says that it should have one teacher as their advisor. Again, we have the arrow on student side. One teacher can be the advisor of many students, but for a student there can be only one teacher as the advisor, and we again have the total participation because for every student we need the advisor. A teacher could have many addresses stored in the system, but an address could belong to only one teacher. So we need to store some addresses in the system. Each address has a unique phone number, a city name, and a street number. So we need some addresses stored in the system. So I will create the address entity. And for each address, we also keep the phone number, the street number, and the city name. And the phone number is unique actually. So I can make the phone number the primary key, and these are the attributes of an address. And teachers have those addresses, right? So these addresses belong to teachers. And it was also talking about the cardinality. It was saying that a teacher could have many addresses, but an address could belong to only one teacher. In this case, addresses are similar to dogs, so I need the arrow on address side. It's reverse. I need to right click and choose reverse to make it correct. So this is our setup so far, and this is okay for our description. It also says that if there is an address stored in the system, it should belong to a teacher. So there should not be any addresses in the corner that does not belong to a teacher. It is saying that if there is an address, it should always belong to a teacher. Therefore, I need the total participation in here as well. If there are such pictures, so in this picture, I have the address. So far, it is in just one relation, right? If I consider course, for example, course has multiple relations connecting the course to the student, connecting the course to the teacher. But for address, I have just one relation. And if I go through the whole description, I will have one relation at the end. And this relation is one-to-many with total participation. And this setup is similar to a weak entity. And if I want to make this a weak entity, with additional assumptions, I can make it into a weak entity. For example, I can think it as, okay, the addresses always belong to a teacher. And if I make this a weak entity, a weak relation, then I can say that, okay, I identify an address through the teacher that it is connected to, through the teacher that has this address. But I can have multiple addresses for a teacher. So instead of saying this is the primary key, I can make it the partial key, saying that, okay, for this teacher, I can store multiple addresses. And within those addresses, I distinguish them according to the phone number. This is not directly from the description. So in the description, it does not say that it has to be a weak relation or a weak entity. But with additional assumptions, we made into a weak entity to show it as an example of that kind of entity. But from the description, there is nothing that forces us to make it a weak entity. For example purposes only, we made this a weak entity with additional assumption. So maybe in the project, in the notes part, I can write that, okay, we assume that since addresses always belong to teachers, they are not uniquely identified by the phone numbers. Maybe let's say that we are not keeping the whole phone number. Maybe we are not keeping the city part of the phone number, etc. Maybe the same address could belong to multiple teachers. So with weak entities, it is kind of hard to find real life examples. So in that case, yeah, for numbers, it will be unique, right? And like in the same address, if we would like to distinguish the different addresses, if the phone number is not enough, we can always include the other information like the city and the street number. So in some case, let's say, if the addresses cannot be uniquely identified, we can make it into a weak entity. Or in the assumptions part, to have a weak entity example, we turn this into a weak entity. That's also okay. If that the entity is in the corner with not many relationships. If I try to make course a weak entity, it will be problematic, because if I make it weak, then through which relation I identify a unique course, for example. If it is according to the teacher that teaches that course, when I enroll the students into that course, I would have some problems. I also need the teacher information, etc. So going with our description, it says that each student can have at most one locker, and each locker could belong to at most one student. So we already have the student entity. Now we are talking about some lockers. And it says that a locker is identified by both its floor number and locker number. So we are storing some lockers in our system. That's an entity. And they are identified by two things: the floor number and the locker number. Maybe you can think it as we have different floors in the building, and in each floor lockers maybe start from 1 to 10, and we need both of these attributes to identify a unique locker, let's say. Then I need to underline both of them to say that this is a composite primary key. So my primary key is both floor number and the locker number. And we were saying that, okay, students, maybe I can carry it around. Students are given lockers. So students, I can write have locker. It was also saying that each student can have at most one locker, and each locker could belong to at most one student. We are setting some upper limits for this relation. And it is saying can, right? So some students may have no locker, and some of them can have one locker. But we are not allowing a student to have many lockers. And on the other hand as well, we are not giving the same locker to multiple students. Some lockers, we don't have student for them. For some lockers, we just have one student. So this is a one-to-one relationship without total participation constraints, because we are not giving lockers to everyone. For some of the students, they don't have lockers. For some of the lockers, they don't have students. And sometimes a padlock can be given to a student for the locker. In this case, the system should keep track of which staff member gives which locker's key to which student on which date. So let's first focus on the first part. We are giving padlocks to the students for the lockers. So it could be a ternary relation. Maybe I might have some padlock information, or I can just put the information about the staff to the same relation. But it was saying that it is only given sometimes. So most of the students who has locker does not have padlocks. For some of them I'm going to give if they want, for example. And in that case, I'm not giving the padlock for the student or not for the locker, but for the activity of having a locker for a student. So I'm giving the padlock only for the students who has locker. So this hints some aggregate relationship. I will create a new rectangle, a dashed rectangle, send it to back, and this new rectangle should include the relation have and the entities that are connected to this relation. So they are student and locker. With students, we have this additional scholarship as well. So it is better to contain it as well. But if it is only including the relation and the entities, this is okay as well. So the important thing is that we should have just one relation within this rectangle and also the entities that are connected to that relation. So we are giving this with the staff members, right? So maybe I can carry the staff member here to see it easily. So I have a give key relationship for the staff member to give a key to the student who has a locker. So the aggregate relation makes sure that whenever a staff member gives key, it is giving the key to a student for having a locker. So this is different from giving the locker the key. So if I give the key to the locker directly, then I can give the key to the lockers without a student. And this is also different from connecting it directly to the student. So if that student does not have a locker, I should not give the key. So therefore, I would like to actually connect the relations together, but that's not how I show it. It's using an aggregate relationship. I say that, okay, this staff member is giving key for a student having a locker. And it was also saying that whenever the staff member gives key, we also store the date information for giving the key. So this is an additional attribute for my relation, and in the end we have such picture, and we can move our items to have a better arrangement, and this is the thing that we have at the end. And in your projects as well, don't expect too much too complicated ER diagrams. Maybe a couple more entities or relations there could be, but for the first stage, first design stage, we expect the similar thing from you. And in this course, the project is not that hard. It's like an introduction to the concepts. We just want you to learn about these different concepts, and we don't expect huge implementations. So that is the end of lab 1. Any questions, problems? Yeah, sure. So in the description, it says that sometimes a padlock can be given to a student for his or her locker. In this case, the system should keep track of which staff member gives which locker's key to which student on which date. So from this last part saying on which date, we should keep this information as well. So we know which staff member because we connect this gives key to the staff member. We know for which student and locker because in the relation has we keep this information. So if I have an aggregate relation in this part, we can understand that as well. But we also need this additional date information, right? It is given in the description, that's why we include this date information. And like the dates, I cannot put it for the have relation because it's not for assigning the student the locker, it's for the date for giving the key. Does that answer your question? So we can include attributes with relations. So that's, for example, for course and students, right? Students are enrolled into courses, and we can store the grade in the relation. that means that so if I store the grade for a course, then for a course there could be multiple students, but then I can just store one grade for the same course. People are going to get different grades. I can also put the grades for the students, but this time the students are going to get multiple courses, and then they are going to get different grades from those courses. To have the possibility to get different grades from different courses and to get different grades by different students, I need to include this attribute to the relation. So attributes in relations are common. Okay. Any other questions, problems? So right now we don't plan to. So labs are not graded. You don't need to upload anything for the labs, but uh, we kind of see how you did in the labs through the project. So we actually explain how to do the steps of the project in the labs. So we don't plan to do any quizzes in the lab so far. Thanks. Any other questions? So if not, we can stop. So we will announce you the groups soon, and we will give you the first step of the project as an assignment. You will basically, as a group, draw the ER diagram for your description. And then we are going to give you feedback later on to fix the problems, etc. So thank you. See you.